Welcome everyone. In this part, question number 201. The thickness of batten plate would be greater than the 1/50th of the distance between the innermost connecting lines or welds. Option A is right answer, true. Question number 202. The perforated cover plates are particularly suitable for a built-up box section consisting of 4 angle sections. Option C is right answer. Question number 203. In a perforated cover plates, the center to center distance between the perforations should not be less than the 1.5 times the length of perforation. Option A is right answer. Question number 204. An eccentrically loaded column is subjected to bending stress as well as direct stress. Option A and B both are correct. So option D is right answer. Question number 205. The design of an eccentrically loaded column should be revised if sigma c dash divided by sigma c plus sigma b dash by sigma b is greater than 1, where sigma c is the allowable working stress in compression in the member subjected to axial load only. Sigma c dash is the calculated average axial compression stress, and sigma b is the maximum allowable bending compressive stress on the extreme fiber, and sigma b dash is the calculated bending stress in the extreme fiber. Option C is right answer. Question number 206. The equivalent axial load is the load of sufficient magnitude to produce a stress equal to the maximum stress produced by the eccentric load. Option A is right answer. Question number 207. Which of the following statement is correct in designing a laced column? Option A is a single lacing system on opposite planes shall preferably be in the same direction so that one is shadow of the other. Right. Option B. The laced compression member are to be provided with tie plates at the ends. Right. To avoid slipping of the lacing bars. Option C. The lacing bar should only be flat angle channel generally. No, it should be flat section. So C is wrong. Option D. The slenderness ratio of the lacing bar for compression shall not exceed 180. No, shall not exceed 145. So both option A and B are correct. Question number 208. If capital A is the cross-sectional area of an eccentrically loaded column and capital Z is the section modulus, then bending factor is equal to capital A by capital Z. Option B is right answer. Question number 209. When the column is subjected to an eccentric load capital WE having eccentricity EX with respect of x-axis and eccentricity EY with respect to y-axis, then equivalent axial load W capital WEQ is given by WEQ equal to WE plus MX BX plus MY BY. Option A is right answer, where MX and MY is the bending moment with respect to x-axis and y-axis respectively, and BX and BY is the bending factor with respect to x-axis and y-axis respectively. Question number 210. A joint in the length of a column is known as column splice. Option C is right answer. Question number 211. A column splice is used to increase the strength of a column. No, column splice is used to increase the length of the column by joining two parts. Option B is right answer, false. Question number 212. When the ends of a column are cut by ordinary method, the load is transferred to the lower column through rivets, and the column splice is designed for full axial load and the other forces to which the joint is subjected. Both option A and C are correct. So option D is right answer. Question number 213. When the ends of the column are faced for bearing over the whole area, the rivets essential to hold the connected members are designed for 50% axial load and other forces acting on the column. Option A is right answer. Question number 214. The allowable working stress in compression in the column splice plates may be taken as 1 to 5 Newton per millimeter square. Option D is right answer. Question number 215. The column splice plates may be assumed to act as short column of zero slenderness ratio. Option A is right answer, agree. Question number 216. A column base is subjected to moment if the intensity of bearing pressure due to axial load is equal to stress due to moment, then the bearing pressure between the base and concrete is 0 at one end and compression at the other end. Option C is right answer. Question number 217. When the upper column does not provide full bearing area over lower column, the bearing plate provided is designed by assuming that the bearing plate acts as short beam to transmit the axial load to the lower column section, and the axial load of the column is taken up by the flanges, and the load transmitted from the flanges of upper column and the reaction from the flanges of lower column are equal and form a couple. Option D is right answer, all of the above. Question number 218. The width of bearing plate is equal to the width of the flange of the column. Option A is right answer. Question number 219. If the moment due to couple in a bearing plate of width B is capital M and the allowable bending stress in a slab or bearing plate is sigma B, then thickness of the bearing plate small t is given by. Option D is right answer, small t equal to root over of 6 into m divided by small b into sigma b. Question number 220. Which of the following statement is wrong? Option A. Columns are supported on column bases. Right. Option B. Column bases transmit the column load to the concrete or masonry foundation blocks. Right. Option C. Column load is spread over large area on concrete or masonry foundation blocks. Right. Option D is right answer, none of the above. Question number 221. For solid round steel column where the load is distributed over the whole area, the minimum thickness of square base small t as per IS 800 1984 is given by. Option C is right answer, small t equal to 3 by 4 into root over of small w by sigma b into within bracket capital B divided by capital B minus small d, where capital W is the total axial load, capital B is the length of the side base, small d is the diameter of the reduced end of the column, and sigma B is the allowable bending stress in steel. Question number 222. The rivets connecting gusset plate and column section are in double shear. Option B is right answer, incorrect. Question number 223. The intensity of pressure between the column base of width capital B and length capital L and concrete will be compressive throughout the length of the column bar and will vary from 0 to 2 into P divided by BL if the ratio of the moment capital M and axial load capital P is equal to capital L by 6. Option B is right answer. Suppose this is the column base of width B and length L subjected to loading P. Okay, so the direct stress will be P by L into B. Okay, and bending stress will be M into Y divided by I plus minus. Okay, so M will be equal to load into eccentricity, A P into E, and I will be equal to B into LQ by 12 and Y equal to L by 2. Okay, so bending stress will be plus minus 6PE divided by BL square. So if we draw the bending stress diagram, so it will be like 6PE BL square, this is minus here, and plus 6PE by BL square positive here. The common stress will be P by L into B plus minus 6PE by L square B. Okay, and the diagram will be like this, trapezium shape. So here the stress value will be P by L into B minus 6PE by BL square, and here the stress value will be P by L into B plus 6PE by BL square. Okay, now it has been said that to make this stress 0, what will be the ratio of M by P? Okay, so this stress value is equal to 0 if we calculate M by P equal to L by 6. Question number 224. When the ratio of the moment capital M and the axial load capital P is less than the 1/6 of the length of the column base, then the intensity of bearing pressure between the column base and the concrete is compressive throughout the length of the column base. Option B is right answer. Question number 225. When the bearing capacity of soil is poor, then the grillage footing should be used as column. Option B is right answer. Question number 226. In a grillage footing, the maximum bending moment occurs at the center of the beam. Option C is right answer. Question number 227. In a grillage column footing, if a column load capital W is distributed through a column base of length small a to the grillage beam of length capital L, then the maximum bending moment capital M is given by. Option D is right answer. Capital M equal to capital W by 8 into within bracket capital L minus small a. Question number 228. In the above question, maximum shear force is equal to. Option A is right answer. Capital W by 2 into capital L into root over into capital L minus small a. Question number 229. In a grillage footing, maximum shear force occurs at the edge of base plate. No maximum shear force at the edge of the loading. Option B is right answer, wrong. Question number 230. After 28 days, the cube strength of a grillage beam should not be less than 16 Newton per millimeter square. Option G is right answer. Question number 231. If overall length of a combined footing is capital L and area of base footing is capital A and the distance between the center of base and the center of gravity of the base is small d, then the smaller with small c for the trapezoidal base of the footing is equal to capital A by capital L minus 6 into capital A into small d divided by capital L square. Option B is right answer. Question number 232. In a combined footing, the shape of the base of footing should be rectangular to support two equal column loads. Option A is right answer. Question number 233. For an economical design of a combined footing supporting two equal column loads, the projection of the beam in lower tier are kept such that the bending moments under the column and at the center of the beam are approximately equal. Option A is right answer, correct. Question number 234. A structural member subjected to tensile force in a direction parallel to its longitudinal axis is called a tensor member, a tie member, a tie. Option D is right answer, any one of these. Question number 235. Which of the following statement is correct? Option A. The term tie is commonly used for tension member in the roof trusses, right? Option B. When a tension member is subjected to axial tensile force, then the distribution of stress over the cross section is uniform, right? Option C. A tension member subjected to axial tension is said to be efficient and the economical member, right? Option D is right answer, all of the above. Question number 236. The tension members are used as hangers for floors. Option A is right answer, correct. Question number 237. The wire ropes, option A, have the advantage of flexibility and strength. Option B, requires special fitting for proper end connections, right. Option C, are used as guy wires with steel stars, right. Option D is right answer, all of the above. Question number 238. A steel wire when used as a tie requires normally pre-stressing. Option B is right answer. Question number 239. A steel rope when used as a tie requires no pre-stressing. Option B is right answer, false. Question number 240. Which of the following is not a tension member? Boom. Option D is right answer, is not a tension member, it is a compression member. Question number 241. The single channel section used as tension member have high rigidity in the direction of wave and low rigidity in the direction of flange. Option B is right answer. Question number 242. The net area of a round bar which resists the tension is the area of cross section at the root of the thread. Option A is right answer. Question number 243. The net sectional area of a tension member is equal to the gross sectional area minus the maximum deduction of the rivet holes. Option B is right answer. Question number 244. In a tension member which when one or more than one rivet hole is of the line, then the failure of plate depends upon diameter of the rivet hole, pitch of the rivets, gauge of the rivets. Option D is right answer, all of this. Question number 245. When the gauge distance is large as compared to the pitch, the failure of section occurs in a straight right angle section passing through the rivet holes. Option B is right answer, disagree. Question number 246. The neat area of flat as shown in the figure 15.17 to be considered in the design will be along 1, 2, 6, 3 and 4. Option C is right answer. Because in zigzag pattern of holes, the neat sectional area will be increased by an amount equal to S square by 4G, where S is the staggered pitch and G is the gauge distance. Question number 247. In a tension member, the failure will occur in a zigzag line if the gauge distance is more than the pitch of the rivets. Option C is right answer. Question number 248. In case the staggered rivets are used in the two legs of an angle section, then the gross width of angle is equal to the sum of lengths of two legs minus the thickness of the angle. Option B is right answer. Question number 249. When a single angle in tension is connected by one leg, the net effective area of the angle AN is taken as AN equal to small a plus small b divided by 1 plus 0.33 small b by a. Option D is right answer, where small a and small b is equal to area of connecting and outstanding legs respectively. Question number 250. When a pair of angles back to back in tension are connected by one leg of each angle, then the net effective area of the section AN is taken as AN equal to small a plus small b divided by 1 plus 0.2 small b by small a. Option B is right answer. Question number 251. A tension member subjected to axial tension is designed on the basis of its neat sectional area. Option B is right answer. Question number 252. Neat sectional area of a tension member is equal to the gross cross sectional area minus the deduction of the rivet holes. Option D, none of the above. Question number 253. If the tension member is normally acting as a tie-in roof truss but subjected to possible reversal of stress resulting from the action of wind, the member should have slenderness ratio not greater than 350. Option C is right answer. Option number 254. In order to determine the gross cross-sectional area of a tension member consisting of two angle sections, the allowance for holes is made as one hole for each angle. Option A is right answer. Question number 255. In order to determine the gross sectional area of a tension member consisting of two laced channels, the allowance for hole is made as two holes from each channel wave or one hole from each flange, whichever is more. Option C is right answer. Question number 256. A single angle steel tie is connected to gusset plates at both ends using rivets. For determining the load carrying capacity of the tie, the allowable tensile stress should be multiplied by the neat area of the angle. Option B is right answer. Question number 257. In double angle section tension member with the angles on the opposite side of the gusset plate, the effective area is the gross area minus the area of the rivet holes, provided tacking rivets have been provided. Option A is right answer, correct. Question number 258. When a built-up tension member is made of four angles with or without plates, then the gross sectional area is determined by making the allowance as two rivet holes for each angle and one rivet hole for every 150 mm width of the plate. Option A is right answer, true. Question number 259. When the radius of gyration of a tension member is smaller, the maximum allowable bending stress in tension is sigma b. The distance to the extreme fiber from the neutral axis is small y, and the bending moment is capital M. When the member is subjected to pure bending, then cross sectional area capital A is given by capital A equal to capital M into small y divided by sigma b into small r square. Option A is right answer. Question number 260. When the tension member is subjected to both axial tension and bending, it should be proportioned in such a manner that sigma t dash divided by sigma t plus sigma b dash divided by sigma b is less than equal to 1. Option B is right answer. Question number 261. When a tension member is subjected to pure axial tensile load P, then neat area required for the member is equal to P by sigma T, where sigma T is the maximum allowable stress in axial tension. Option A is right answer, correct. Question number 262. The load which produces the average axial tensile stress in the section equivalent to the maximum combined stress at the extreme fiber of the section is known as equivalent axial tensile load. Option A is right answer. Question number 263. The Indian standards recommend that for a splice plate, rivets or bolts carrying calculated shear stress through a packing greater than 6 mm thick should be increased above the number required by the normal calculation by 2.5% for each 2 mm thickness of packing. Option D is right answer. Question number 264. A beam is a structural member subjected to transverse load. Option B is right answer. Question number 265. Which of the following statement is correct? Option A. The length of end connections of angle or channel section to a gusset plate is reduced by the using lag angles. Right. Option B. When the lag angles are used to connect an angle member, the gross area of the member shall be taken as effective. No. Option C. All rivets connecting lag angles and gusset plates are provided less than the number of the rivets required by computation. No. So option A is the correct statement. Question number 266. The main beam is a beam which supports secondary beam. Option C is right answer. Question number 267. Any major beam in a structure is known as girder. Option C is right answer. Question number 268. Joists support floor construction only. Option A right. Question number 269. In roof trusses, the horizontal beams spanning between two adjacent trusses are known as purlins. Option C is right answer. Question number 270. The beams resting on purlins are known as rafters. Option B is right answer. Question number 271. The beams at the outside wall of a building supporting its share of the floor and also the wall up to the floor above it are known as rafters. Option B, no. Question number 272. The beams supporting the stair steps are called stringers. Option D is right answer. Question number 273. A rolled I section provides large moment of inertia about x-axis with less cross-sectional area, large moment of inertia, large moment of resistance as compared to other sections, greater lateral stability. Option D is right answer, all of the above. Question number 274. The rolled steel channel section are used as purlins. Option A is right answer, true. Question number 275. Which of the following statement is wrong? Option A. The rolled steel channel section are unsymmetrical section about y-axis. Right. Option B. The rolled steel angle section are unsymmetrical section about both x-axis and y-axis. Right. Option C. The rolled steel T section are used as beams in the rectangular water tanks. Right. Option D. None of the above. Statement is wrong. Question number 276. For a beam in equilibrium, the moment of resistance is equal to the bending moment at this section. Option B is right answer. Question number 277. In case of bending of beams about one axis, the load is considered to be applied through the shear center of area of the beam section. Option A is right answer. Agree. Question number 278. In angle and channel section, the load does not pass through the shear center. Option B is right answer. Question number 279. When the load does not pass through the shear center of the beam, it produces torsional moment along the bending moment. Option C is right answer. Question number 280. The bending stress in a beam at a neutral axis is 0. Option A is right answer. Question number 281. When the load is acting downwards in a simply supported beam, the bending stress is maximum at extreme fiber and compressive above the neutral axis. Option D is right answer, both A and B. Question number 282. When the load on a simply supported beam is acting downward, the bending stress is tensile below the neutral axis. Option A is right answer. Question number 283. The shear stress in a beam at neutral axis is maximum. Option C is right answer. Question number 284. For simply supported beams, the shear force is maximum at the supports. Option A is right answer, correct. Question number 285. The average shear stress for rolled beam is calculated by dividing the shear force at the cross section by the gross section of the wave. Option C is right answer. Question number 286. The gross section of the wave of a beam is equal to the depth of the beam into wave thickness. Option C is right answer. Question number 287. The average shear stress on the gross section of wave when wave buckling is not a factor should not exceed 94.5 MPa. Option C is right answer. Question number 288. When a beam is subjected to coexistent bending stress sigma b and shear stress tau, then the equivalent stress is equal to root over of sigma b square plus 3 tau square. Option C is right answer. Question number 289. The equivalent stress should be less than the maximum allowable equivalent stress. Option A is right answer. Question number 290. The maximum allowable stress for rolled steel beam and channel is 228.5 MPa. Option D is right answer. Question number 291. The maximum deflection for a simply supported beam should not exceed 1/3 to 5 of this span. Option C is right answer. Question number 292. A rectangular beam of width 200 mm and depth 300 mm is subjected to a shear force of 200 kN. The maximum shear stress produced in the beam is, look, we know average shear stress tau AB equal to shear force F divided by dimension of the beam B into D. Okay, in Newton per millimeter square or in MPa. So if we put the value of F and B and D, we will get the value of average shear stress tau AB equal to 10/3 Newton per millimeter square. And we also know that maximum shear stress tau max equal to 1.5 into tau average. So if we put the value of tau average 10/3 in this equation, we will get the maximum shear stress tau max equal to 5 Newton per millimeter square. Option B is right answer, 5 MPa. Question number 293. A symmetrical channel section is made of a metal which is equally strong in tension and compression. It is used as a simply supported beam with its wave horizontal to carry vertical loads. Strongest if the wave is used as top face and strongest if the wave is used as a bottom face. Option C is right answer, equally strong in both A and B. Question number 294. The large deflection in beam may result in cracking of ceiling plaster indicate lack of rigidity, may cause distortion of the in the connection. Option D is right answer, all of the above. Question number 295. The deflection of the beam may be decreased by increasing the depth of the beam. Option A is right answer. Question number 296. The beam having lateral support from the other members may buckle between the points of lateral support. Option A is right answer. Correct. Question number 297. The torsion restraint can be provided by providing wave or flange cleats in the end connection, bearing stiffeners acting in the conjunction with the bearing of the beam, and external support to the end of the compression flange. Option D is right answer, all of the above. Question number 298. The effective length small l of a simply supported beam with ends restrained against torsion and end of the compression flange fully restrained against lateral bending is equal to 0.7 into L, where capital L is the span of the beam. Option A is right answer. Question number 299. The effective length small l for cantilever beams built in at support with projecting length capital L and free at the end is equal to 0.85 into capital L. Option C is right answer. Question number 300. The effective length small l for cantilever beams continuous at the support with projecting length capital L partially restrained against torsion at the support and free at the end is equal to 2 into capital L. Option C is right answer.